All right, so for as long as we've been looking up at the stars, we've had this dream, right? The dream of finding another Earth out there. It feels like the ultimate cosmic scavenger hunt, the search for our planet's twin. But what if the travel brochure kind of glosses over the deadly fine print? Yeah, you heard that right. See, here's the thing about interstellar real estate. Just because a planet is in the habitable zone, that sweet spot where water could be liquid, it doesn't mean it's actually, livable. In fact, most of these supposed paradise worlds are actually cosmic death traps. So how about we take a little tour? First things first, what's an exoplanet? It's simple, really. It's any planet that's orbiting a star that isn't our sun. And we've found thousands of them. But let's look at our first destination, K218b. This thing is a super-Earth, maybe a gigantic ocean world. And get this, we recently found dimethyl sulfide in its atmosphere. On Earth, that gas is pretty much only made by marine life. Sounds super promising, doesn't it? Well, just hold that thought. Okay, welcome everyone to the Exoplanet Death Tour. We're going to follow let's call him our unlucky volunteer, an astronaut named Chase, as he finds out the hard way why you should always read the reviews before booking a trip across the galaxy. First stop, TRAPPIST-1b. I mean, it's close, it's Earth-sized. What could possibly go wrong? Well, it orbits its star 90 times closer than Earth orbits the sun. So even though its star is a pretty cool red dwarf, the surface is a blistering 225 degrees Celsius. That's literally the perfect temperature for a frozen pizza. Chase lands and, yep, he's not exploring, he's baking. Next up on our list is Kepler-22b. On paper, this is the dream. An ocean planet orbiting a star a lot like ours. But the atmosphere is so unbelievably thick, the pressure is so intense, that the water isn't really liquid or gas. It's this bizarre, soupy, supercritical fluid. So when Chase goes for a swim, the crushing pressure instantly collapses his lungs. So much for a beach vacation. Okay, what about our actual next-door neighbor, Proxima Centauri b? This one is tidally locked. That means one side is forever scorching hot, and the other is forever frozen solid. Chase thinks he's clever. He sets up camp right in the middle in that little twilight zone. Smart move. Until, bam! Its moody star burps out a massive solar flare with no warning. 1 second you're fine, the next you're vaporized by a wave of radiation. So let's just do a quick recap of the carnage, shall we? K218b, crushing pressure. TRAPPIST-1b, cosmic oven. Kepler-22b, lung imploding pressure. Proxima Centauri b, surprise radiation bath. You starting to see a pattern here? That word habitable is really doing some heavy lifting in these press releases. But hold on a second. This all brings up a really good question. I mean, we've never actually been to these places. So how in the world do we know their atmospheres have crushing pressure or that they're hot enough to cook a pizza from light years away? Well, the answer is one of the coolest, most clever tricks in all of astronomy. We basically get to be cosmic spies. And our secret weapon is something called transit spectroscopy. Let me break it down for you. When a planet passes, or transits, in front of its star from our viewpoint, a little bit of that starlight shines through the planet's atmosphere. Now, different gases absorb different colors of light. So by using these incredible tools like the James Webb Space Telescope, we can see which colors are missing from the starlight. And that tells us exactly what's in that planet's air: methane, CO2, water vapor, maybe even something more interesting. And right there, that something more interesting brings us to the biggest question of them all. When we say we're searching for life, what are we actually looking for? Because it's probably not little green men. The key word you need to know is biosignature. It's not a spaceship or a radio call. It's a chemical fingerprint that points to life. Remember that dimethyl sulfide we found on K218b? That's a potential biosignature. Finding it doesn't mean we found advanced aliens, but it could mean that world's oceans are full of something like phytoplankton. We're not looking for ET, we're looking for alien pond scum. And that leads us to this: great, cosmic, and kind of creepy silence. I mean, think about it. The universe is billions of years old. There are hundreds of billions of galaxies, each with hundreds of billions of stars and probably trillions of planets. The odds are overwhelming that someone else should be out there. So, as the physicist Enrico Fermi famously asked over lunch one day, where is everybody? This is the Fermi Paradox. It's this huge, nagging contradiction. The math says the universe should be absolutely teeming with civilizations, but when we look, we find nothing. Just silence. The possible answers are just mind-bending. Maybe there's a great filter, some hurdle that almost no civilization can pass, and we're either approaching it or we're already past it. Or there's the zoo hypothesis, that they're out there watching us but have a strict do not interfere policy. Or maybe the universe is just so big and civilizations are so far apart in space and time that we're like ships passing in the cosmic night. Or maybe the most terrifying answer of all is that we're the first, that we're alone. But you know what? Even with that huge, spooky question hanging over our heads, we don't stop looking. That search for another Earth, for any kind of life, is one of the most powerful things that drives us to explore. And it turns out, our own little corner of the galaxy is way more interesting than we ever thought.
Let's just go back to that TRAPPIST-1 system for a second. It doesn't have 1 or 2 Earth-sized planets. It has 7 of them, 7 worlds, all roughly the size of our own, all packed in an orbit smaller than Mercury's. And one of them, TRAPPIST-1e, is smack dab in the middle of the habitable zone. It's our best shot right now, our current frontrunner for a true Earth 2.0. So, at the end of the day, maybe the point isn't just to find a perfect copy of home. Our little death tour proves that's probably not going to happen. But every single one of these deadly, fascinating, imperfect worlds tells us a story about how planets are made, how life might start, and where we fit in this giant silent universe. The real adventure isn't just finding a new home. It's about understanding all the other ones out there.